In this first video on Kirchhoffs laws, I'll explain the principles of Kirchhoffs laws and I will show you how we basically do them. But there'll be a second video which shows you how to do an example. And that's taken from my sculpt, so the mention of homework, just ignore it. But it basically gives an example of how to do them. Kirchhoffs laws, some people find them fun, some people find them tricky. There's two principles though with Kirchhoffs laws. One is sort of like the voltage law, if you like, and one is the current law. And one basically says that if you go around a loop in a circuit, this is voltage law I'm talking about, a closed path in a circuit, the potential voltage is zero. So if you go around a closed path, summing voltages, they will sum to zero. Alright, what does that mean? Alright, let's have a look. It's like this. Let's call that E, let's call that R1, let's call that R2, let's call that I. What they're basically saying is if I sum up all these voltages, now current's not a voltage, but IR1 and IR2 are voltages. Now this is like you've made a voltage and this is like you've used a voltage. So this is like a positive voltage and these are like negative voltages. So if we go E plus IR1 plus IR2, it will equal 0. Now we're going to have some rules and I'm going to talk about them in a sec. But basically what I've said here is that this EMF is a positive voltage and these are negative voltages. And if we add them all up, they'll add to 0. Basically what we learned, hopefully in year 10, year 11, year 12, that as you go around a loop in a circuit and add up the voltages through the resistors must add up to that guy. So if we treat those as negative and that as positive, they're going to equal 0. The actual law is if you go around a closed path, summing voltages, they will sum to 0. Now, what are we talking about here? We're talking about energy. So if they ask you what this means, it's conservation of energy. This is like heights. This is like saying if you go up a 100-meter ladder, then, and you come down ladders, when you get back to the ground, you must have come down 100 meters. It's conservation of energy. Now, the current law is the other one. And it basically says, at a junction, what's a junction? It's where you've got maybe 3 wires joined together, right? Or what have you. Junction. It says current going in must equal, sorry about that bad cue, current going out. So if that's I1, that's I2, right? We can't have I3 going in. You can't have a whole bunch of current going into a junction and disappearing unless it had a little black hole there. Just joking about the black hole. If this is the way the circuit really is, then what we're basically saying is that I1 plus I2 must equal I3. Those are the two laws, and you need to know them. I think what I'll do is I'll explain the next bit in another video, how to use it.